I'm going to give you the boring stuff about myself, and then we'll get into some like videos and stuff like that. So I went to the University of Alberta in Edmonton, way back when video games were much smaller, consoles were much smaller, hardware was a lot simpler than it is today. And I actually got interested in computers I had a Commodore 64. And yeah, so I'm really old. And when I got games on that thing, I found it a lot of fun to just kind of break into them and make it so I couldn't die or give myself infinite lives. And a lot of the early programs, that was really easy. They were written in BASIC. You could just search through the code and you'd see, oh, lives equals lives minus 1. No, plus 1. So now I get an extra life every time I die. And you do stuff like that, it'd be fun. And I actually enjoyed breaking into games almost as much as, or more sometimes, than playing them. So that really got me interested in computing science. I went to the university, got a degree, undergrad degree in computer science, and then ended up working for an instructor over the summer, and then that kind of led to maybe I'll stick around and do some master's work. So I did 1 year of my master's in computer graphics and virtual reality. We had some of the highest end graphics hardware at the time in the lab, including high-end goggles for doing VR, complete with the wide-angle lenses. So the lenses were really heavy glass to give you a wide field of view. You had to have a counterweight on the back of your head to wear the VR helmet. And it used a magnetic sensor, which is still not being used today, even though they're probably one of the most accurate sensors for detecting tilt and rotation and position. So I was doing a bunch of VR stuff. And then in Banff, they had kind of a setup. They had like millions of dollars worth of computers, refrigerator-sized stuff. And they were just kind of doing it for art. They had grants from the government, and they had all this money. So I worked there for a while. That was a lot of fun. Did virtual reality there for some artists. And you can find some of that online, actually. I don't know if it's on YouTube. But there's some of that. And then that was funded by the government. The funding got cut. So I went looking for work. Ended up at the Simon Fraser University Graphics Lab, where they were looking for people who had VR experience because they were doing a VR demo. And then while I was there, I found out about EA. And EA was looking for somebody to help with their motion capture. They were just transitioning into 3D at that time. This was the time when games were kind of just edging into doing 3D stuff. So, okay, well, let's look at what they've got to offer. It sounded like a lot of fun. They had a lot of high-end hardware. They were doing motion capture. And they needed that data in games. And it was funny because the motion capture studio, unfortunately, won't be on the tour, but it's one of this huge building that you probably passed on the way up the hill. I'll probably be able to show it through one of the windows. Massive, massive building. You'll see actually some of it in one of the videos with Rick Mercer. How many people have seen the Rick Mercer thing with EA? Yeah, so I'll show you that clip. Well, the original motion capture studio was probably smaller than this room. It was in an old metalwork shop in some back alley with tarps on the roof to prevent it from raining. Because EA was like, is this going to catch on or not? They didn't even know whether it was going to be viable for games. So they didn't want to buy some big building or rent a big building. They just wanted to kind of test it out. Well, it worked. It worked really well. And it was a lot of fun. We were getting this motion capture data into art tools and stuff like that. But what ended up happening was that this data was a huge amount of data. You're capturing at maybe 120 frames per second this data. So for an artist to go in there and go, well, you know, you captured this, but it's not quite right. There were no tools for editing that data. They were used to keyframe animation, where it's like, I adjust this keyframe, and you know, maybe that's somewhere in a 2-second span of animation. I can adjust it, and it's going to blend through that. Well, not with motion capture. This points all the way along. You move one point, and you basically get this blip in the animation. It's not smoothed out. So we needed a lot of tools, and I helped write a lot of those tools to get the animation smooth and stuff like that. So that was my job. I moved into doing a lot of stuff with a lot of our 3D graphics content, being able to get content in and out of artist packages and into our own custom pipelines, and then into games, so that the games could actually get it. So that was a lot of fun. Worked on facial animation and a bunch of different things. I now currently work on a central animation tool, which is called ANT. If you do a search for electronic arts and AMP, you'll get lots of videos and stuff on it, and there'll be people talking about it, about how it was used in game development. It's used in sports games. Battlefield 3 recently used it, and a lot more games are coming online that are going to use it. So that's a bit about me. I'm going to switch now to, let's do a history of EA.
This is the story of the birth of a shining star.
I tend to come to work every morning really looking forward to getting in here and working with all the people I work with.
I elected the chance to come across here and to work with such great minds and brilliant people.
This is the story of homegrown success.
It's an amazing place. The people here, the talent that produces the games that we have, it's incredible.
I've been here for my 12th year. I've been with the company, and it's hard to imagine what else I might be doing with my life.
It's very exciting to be able to wake up in the morning and come into a job that I love.
This is the story of Electronic Arts Canada. In 1982, the PC market was burgeoning, and Don Matrick and Jeff Sember saw an opportunity. They decided to spend their summer vacation working in their parents' living room, building a game that was true to their hearts.
We started from next to nothing. Two guys in a basement making a game, and pretty soon it became the largest game enterprise in the world.
It was called Evolution, and it represented a revolution in gaming.
Evolution was this huge local phenomenon of two Burnaby boys.
People didn't know that video games were going to be a big thing.
Encouraged by their phenomenal success, they formed Distinctive Software Incorporated. Meanwhile, some 800 miles away, Trip Hawkins creates Amazing Software, a company where the philosophy was that as electronic artists, the programmers were the true rock stars of the industry. In 1991, Electronic Arts purchased Distinctive for an unprecedented $11 million. It was a coming of age and the birth of a new brand.
We'll take the flip, the kick, the headbutt, and the taunt. Or throw in that and that. Looks good. We'll take the face-off, the howitzer, and the deke. Give me that kick save. Give me the biscuit. Give me those skaters. Give me him some of that. One of those. Showtime. Take his move, his move, his move. Give me Freddy, Fuzzy, and the Walrus. Not that one. That one. EA Sports to the game.
It's difficult to explain how, from a very early age, anyone in Europe or South Central America kind of grows up with football being their daily life.
We know that football is a global passion. It's been amazing for us to have, a product that has, a lifetime sold $2.5 billion.
FIFA is our largest selling game. It has giant worldwide appeal, of course, because so many people are fans of soccer, or as they would call it, football.
FIFA's one of the longest running franchises as far as I know, starting in the mid-1990s, and definitely one of our best selling games.
FIFA's one of those games that some of my friends from the UK always bug me about. What do Canadians know about making a footy game?
Before I arrived here, it was quite entertaining to consider that the kind of leading football video game in the world was being developed in a great big city in Canada.
Our history has really been built around making sports products.
Within a short period of time, growth exceeded capacity, and the studio realized the need to move once again.
The official opening day, the Prime Minister, Jean Chrétien, came in.
It is with a great deal of pride that I was there that day when he came in. Prime Minister of Canada, the Right Honourable Shaun Halliday.
And we put him in an NHL shirt.
They had an exhibition where he took some hockey shots on goal.
That day was just such a blur. Just everyone was so excited.
2005 saw the motion capture studio become a bigger and more important part of the new campus. Sports heroes and movie stars came from around the world to be captured and put in the games. Electronic Arts Canada decided to leverage this star power to help make a difference in the community it grew up in.
We're doing up to 60 tours a year for kids with life-threatening illness through Canuck Place, Ronald McDonald House, kids referred through from BC Children's Hospital, through the Oncology Clinic, through the Child Life Services, to the Make-A-Wish Foundation to doing wish enhancements.
Electronic Arts Canada has also donated over $100,000 to local high school programs.
We've actually been able to reach over 1,000 kids in the last year in terms of our Believe and Achieve educational programs for grade 10 to grade 12 students.
It's very important for a company that makes a lot of money to contribute back to the community.
Ultimately, the stuff we work on gets seen by, literally millions of people.
I get to see and get hands-on experience with all of the games that we make here.
Like FIFA, NHL,
Facebreaker,
March Madness,
NBA.
For me, I just think it's just so exciting to see the variety of stuff we do.
SSX. I love that game.
These are older videos, so.
From the basements of Burnaby to the campus on the hill, the legacy lives on. Electronic Arts Canada continues to define and shape an industry, and it's a great place to work.
When I came to Electronic Arts, I knew I wanted to come to an NHL team one day, so now that I am, I'm feels like a dream.
I am really proud to be part of the EA family.
Working at EA is definitely something I'm very proud of. It means a lot to me, and I'm doing what I love.
I feel very blessed to be leading such an organization.
Okay, so we'll move on a bit. So this is an aerial view of our campus.
I actually have
So where are we now? Basically, this is the. You look straight out the doorway there. That's the. You'll see the basically. On my mouse. Oh yeah. Basically, that's that door here. So we're just on the other side of that, and then if you went straight out there, you can go down to the parkade or go down to the soccer field level. And my office is over here. So this is all addition over here. This is our phase 2. Over here, which is not even in the picture, is for most of it is motion capture studio over here. So you'll see we've actually won quite a few awards for our building because we've got a lot of green spaces on the roofs. So it's as you see in the tour, it's quite an amazing building. We have a lot of facilities inside the building. We have our own indoor gym. We have our own indoor basketball court with hardwood floors, as you see. Cafeteria, we have our own library with all kinds of video games, books, magazines, all kinds of films, all that kind of stuff. You can borrow hardware, video games, all that kind of stuff. There's various areas that you can sit down and try various games. And then there's various lounges. I'll take you through to this one as well, and then the gym. So lots of different areas throughout the building to keep the employees happy. Just going to go through some of the sample careers, just to give you an idea of, because you think, oh, video games, what kind of people make video games? Well, there's lots of different career paths to be involved in video games. My closest one that I'm going to talk to the most is game programming, or at least programming in general. Because as you'll see, I'm not actually a game programmer. I've written code that ends up in games, but I don't work for a game team. I work for a central technology team. So on central technology, we develop software or tools that all kinds of game teams use. So I've got software that's being used by pretty well every game team within the company. So it's a little different role, but it's the same set of skills for the most part. So our titles are called software engineers. We do the programming. And we basically are there to write code. So I don't know how many people have started learning some programming. So you guys have learned a bit of programming. Good. So lots of different languages. Sometimes it's low-level, hardware-specific languages, like writing code for the PS3 special processing units. C++ is used quite heavily in game programming. C# is used quite heavily for tool development. And then sometimes there's other scripting tools that are used for kind of tools that are processing data. So they might use Python or Perl or whatever. But the main programming languages are C++ and C# by far. There's different types of engineers that do different jobs. You have user interface programmers that do a lot of the menus that are in the game. And some games have a very extensive menu system because you can pick your team, you can pick your player, or you can maybe pick your car and what decals you want on it. All that kind of stuff comes into the interface. There's the AI programmers that do artificial intelligence. This is basically the gameplay, how players react and stuff like that. Although that area is kind of a bit foggy now because, like, for example, the tool I work on, the animation tool, it actually lets you, like an artist, author a lot of the AI. So they can kind of start saying, they can design, for example, what we call a state flow. And it's like, okay, I'm running, but if the user pushes this button, then I'm going to, turn to the right or whatever. So they can do a lot of that and tell it, okay, I'm going to transition to this state or this state. And so a lot of the logic and stuff like that is not necessarily programmed by writing it in code. A lot of it is authored by using higher level tools that kind of let them define state transitions for characters and stuff like that. Then there's rendering. These are the people that try to make the games look amazing. Audio is a huge part of a game. Most people just kind of take it for granted, especially if you don't have a really good sound system. But if you've got a really amazing sound system, our games are one of the best in terms of the quality of the sound. It'll fill the whole room for you. It's really an environment that you want the person to experience. Then there's people who work outside the actual code that goes in the game, and they look after things like making sure that the game builds. Because a lot of times they're developing the game on more than one piece of hardware. So it might be a game that's going to ship on the PC, the PS3, and the Xbox. So in order to do all that, essentially you edit one piece of code, check it in to a server, then the build farm will pick up that code, compile it automatically, check for any compile errors, maybe email them out, whatever. So it's not just kind of like, one person working at a desk working on something. This is a whole team environment, so you've got a whole bunch of servers that are managing code revisions, all that kind of stuff. And then there's tool development. So a lot of work that goes into producing a game isn't just writing the code. In fact, I would argue that more work goes into getting content into the game and the tools that are around that than there is actually writing the game code. So you've got artists who need to edit data. A lot of that is done through off-the-shelf tools like Maya, Motion Builder, maybe 3D Studio Max. They do a lot of editing in that environment. And then they need to get that data out of that environment and into another environment that allow them to put it into the game. And a lot of times, they're really just kind of editing parts of a world, right? So in Maya, I might be just editing a building, but then some other piece of software needs to say, well, how do I put a level together? Well, I want this building from here, or I want this stadium from here, and all those kinds of pieces need to come together. Especially if you're putting together a roster of players like on FIFA. There's like 600 different characters or something like that they can put together. So, maybe it's an old, you're playing a retro game, so they're wearing different uniforms, all that kind of stuff. So there's tools that let them kind of composite these characters together and look at them. A lot of work goes into that as well. And then networking, all the games that do networking code, that stuff's really complicated, making sure that two games that are running on different computers actually stay in sync. You don't want one guy to think that he's dead and the other guy saying, no, I'm still alive. That kind of stuff is very complex to get right. So how do you get in the game for some of this stuff? If you want a software engineer, you typically need 4 years of post-secondary education. Typically that's a degree in computer science, software, computer engineering. You're going to be looking at courses, advanced courses in math, typically calculus and linear algebra, physics, dynamics, kinematics, programming languages, concurrent programming. Concurrent programming is where you basically, you guys haven't done this yet, but you write a program and it just kind of does one thing. Well, not in a game. Because at the same time, there's AI running, there's audio running, there's rendering running. They're all running at the same time. So it's kind of like multiple programs all running at the same time, and they all need to communicate to each other. Very complicated stuff. Low-level topics, machine language, system architectures, optimization, making things run faster. A lot of that means really understanding hardware, understanding the low-level instructions on that hardware. It's just like you can do the same thing 10 different ways. One of them might be 100 times faster than the other 99. You got to find that one, otherwise your game's not going to render fast enough or be reactive enough. So a lot of that going on. So these are the areas that you think your strong points are. You enjoy these things. You enjoy math. You enjoy physics. You enjoy programming. Engineering might be your area. If not, one more slide here. So how to get a head start now? Obviously, high school courses where they're available. Math and physics are an option. Take them. Do small projects. Definitely, you guys are playing around with Game Maker and stuff like that. That's great to start. But at some point, you're going to want to start downloading some code off the internet of examples of mini games, stuff like that, and start running them, and then changing them and say, hey, I know how to do this and do that. Or maybe there's mods out there for existing games that you can get involved in, or even just start creating your own simple game. And I've hired several co-op students, which I'll get to later, co-op students at universities who, when they're not taking courses, they're trying to get hired on at businesses. I've hired a countless number of co-op students over the years. It's generally not just their grades that we look at. It's not even a lot of the times the first thing we look at. We want to see their portfolio, right? Yeah, we know you're busy with your schoolwork, but hopefully you've had some time to fool around on some pet projects. What have you done in that? What kind of projects have you written? What have you learned from that? That's the kind of thing that we want to look at, because if you've got a whole bunch of students applying, they all got good grades. Now what, right? There needs to be something that sets them apart. So it's really showing that initiative that you went and did something. There's lots of different competitions that you can get involved in. I'm sure your school math department can tell you about those. Talk a bit about artists who make games. Who likes creating things in 3D software or drawing or painting, those kinds of things? Yeah, so there's a lot of technical skills that are required, but mostly it's an artistic skill, right? So there's a lot of different types of artists, concept artists. If you ever watch any of the DVDs where they do the special features, a lot of times they'll show you storyboards and all that kind of stuff. Very similar in games. There's a lot of storyboards and concept art that's created. And a lot of this could be just done by hand on paper or and sketches and stuff like that. We have artists that are doing that. And we have modelers. Modelers are the people who actually put together the meshes, right? Move points around, that kind of thing. And they get the form of a character or a car or a building. Then you have texturers. Texturers are the ones that actually put the images on things. So if you've got like a brick texture that needs to go on somebody's face needs to be textured on, right? That's aligning an image with the underlying mesh. Then you have lighters who adjust basically the surface qualities of an object to make it look shiny or reflective or whatever. And if it's a building or an environment that needs lighting, they would do that. Then you have animators who obviously make things animate. They put skeletons under characters, animate them, make sure that they look realistic, those kinds of things. Clean up motion capture data or change it to be maybe more exaggerated than what a normal human being could actually do. But it's a game, right? So you want to exaggerate it sometimes. 2D artists, they're the ones that would be actually painting textures and stuff like that. Maybe the front end of a game with the menus, the artwork and the 2D artwork that's in there might be there. And then various effects artists for doing particle systems and explosions and stuff like that. Getting in the game, demo reels, right? If you're going to do artistic stuff, download some of the software that's out there. There's lots of free versions of this stuff available. Fool around with Photoshop, Illustrator, Maya. A lot of these are free for students. They'll have a big, student copy kind of watermark on them, but you can use them and you can fool around with them and, render stuff out and use that as a demo reel and say, hey, this is, some character animation stuff that I did or whatever. The cool thing about this is that, you can get a long ways without, taking 4 years of university. If you've got the skills and you sit down and work with this software, you can come up with a really impressive demo reel that might get you in the door. So I think I kind of basically said this, right? Learn 3D software, for example, Blender. Take traditional art courses. So, I mean, a lot of this just means fooling around with the software that's out there. Game designers, they create the story, design levels in the game, develop the look and feel of the game. What do they need? Again, they're going to want to have a portfolio with some design work, some projects, ideas, degree, an understanding of what makes games fun to play, ability to document, communicate ideas, and excellent communication skills. So, you know, it's stuff that you can quite easily get well at if you've got a keen interest in it and you just work at it. Again, getting a head start now, learn about the games industry, join a game design club, write down game ideas, create game design documents, and make a game yourself or with friends. Get into that team environment, get a great idea out there and pitch it. Game producers, they develop the look and feel of the game, to make the business decisions and know the market and competition. So this is a pretty high-level job. This is somebody who really knows whether or not this game would sell. And that's a really tricky thing, because a lot of the times, a lot of people are like, oh, that would be an awesome game. But you don't really know how many people would think it would be awesome. And it might be a really awesome game. And there might be, 1% of the people who think it's the best game ever played. But it's only 1% of the people. And the cost of developing it compared to the sales that you'll get for this game just don't outweigh it. These are the kind of people that kind of figure that stuff out. Because unfortunately, a lot of games that are extremely fun for some people just can't be produced because they're too expensive to make for that few people who would like it. But getting in the game there, you want a diploma or degree, you need effective communication skills, strong knowledge of the video game industry and trends. So that's knowing, hey, you know what, this type of game is really becoming popular, right? If you were somebody that said, you know what, a game like Angry Birds is going to do extremely well, right? Knowing that ahead of time and then being right about it, that would give you a lot of credit, right? If it was just a fluke that it did well, that's something else. Getting a head start, like a game designer's producer should learn about the games industry, take leadership roles on teams, develop communication skills, start a small business, any kind, and learn from your mistakes. So this is people who are really interested in the business side of games. So, co-op program. So, when you get to university, if you take, pretty well I think most of the universities in the Lower Mainland we have co-ops with. So we deal with Simon Fraser University, UBC, UVic, a bunch of them. You get on there, that's where right away you're going to want to start showing that you're interested in games, doing a project or whatever. Because you all are going to be able to apply for the co-op program, and resumes. We quite frequently hire co-op students. There's several of them in the building right now. It's a great way to make money, get experience, and learn a lot, and obviously increase your chances of working in the games industry, either here or another game company. I've hired several co-op students who've gone on to either work here or at other game companies, so it's definitely probably one of the easiest ways to get in the game to show that you can do it.